So I'm Dr. Shalom Armstrong, Assistant Professor of Soil Science and Agronomy at Illinois State University in the Department of Agriculture there. I'm also working along with Dr. Catherine O'Reilly, who's in the Department of Geology. And the farmers that I'm working with are Philip Brown and Mike Kelly. They've been awesome to help us get things installed. And also I have 3 graduate students that are doing most of the work for our study. So, low. Took a lot of time, now you're taking it. All right, so I'm going to skip some of the intro except for a couple of slides because Lo did a good job of covering some of the dynamics that we're having to deal with today. And then I'm going to give you an idea of how we came to the point to do a field scale study with tile drainage and cover crops involved, okay, based on some plot scale observations. So we know that we have predicted that we need a 45% loss by year 2025, and for nitrate, that's specifically a 15% reduction in what's hitting surface waters. So one of the things I thought about when I looked at the landscape and how nitrogen is being managed in central Illinois, northern Illinois, and the entire state, we have to consider introducing or developing some management plans to speak to all of the different types of nitrogen management, both fall and spring, if we want to meet that lofty goal of a 15% reduction of nitrate over by 2012. So here's just one study that one of my colleagues conducted, Dr. Smikolas, Kenneth Smikolas, in the Lake Bloomington watershed 2008. I like this slide because it really shows the impact of timing and how that reduces nitrates concentrations that is getting to the tile drainage. Right? When you look here, there's fall with and without inhibitor, and you can see the range, 30 to 43 ppms of nitrate. Then there was a reduction when you added, when you applied that nitrogen in the spring with and without an inhibitor. Okay, and then guess what this is? This is the control where there was no nitrogen added. And it's at 15 to 23 ppms that particular year, okay? And the EPA standard is 10 ppm. So when I saw this slide coming in as a young professor, I immediately knew that there was a lot of work being done here as far as how to reduce nitrogen loading to surface waters when you are adding it in the spring, and how spring does have an impact. But then I was really concerned with the fact that when you don't add any nitrogen, you still get concentrations in your tile above the EPA standard. Okay, that's due to high organic matter soils. Okay, you think about this work that was done in Iowa by Tom Casper, really good work. So what he did was he combined spring application of nitrogen with the use of cover crops. Okay, and you can see across the board, your initial observation should be that there was a significant reduction in the amount of nitrogen lost by tile drainage when you had spring application plus the benefit of cover crops, whether that was cereal rye or oats. Okay, but the next thing that I thought about as a scientist when I'm looking at this graph is that, you know, in the soybean years, we're losing upwards to about 60%, 66% of what we normally lose in the corn year, and we're not applying any nitrogen. So that's that residual nitrogen and the nitrogen that's the product of nitrification and mineralization of just high organic matter soils. So then cover crops could help both the spring and just if you have that nitrogen that's in your high organic matter soils that are leaching and being intercepted by tile drainage, cover crops could possibly impact that, okay? Now this is wonderful. This is awesome that we know that you can apply the nitrogen in the spring, get a reduction. Then we know if you add cover crops to that, you can get another reduction. But, you know, in central Illinois, it's not many farmers. Well, at least half of the farmers are applying that nitrogen in the fall, okay? And when you think about farmers' cover crop, in the last survey, stated that in Illinois, I think about 11 to 13% of farmers had experience with cover crops within the last 5 years. So we're not, half of our farmers are not applying the nitrogen in the spring currently, right now. And then majority of our farmers do not cover crop. And so my efforts have been to increase the adoption of cover crop, okay? And here's a window. This is 2011, this is the EQIP cost share program, and this shows the progression and adoption over a 3-year period, okay? Just a window, because there are a lot of farmers who cover crop without the cost share program, okay? It's just a window to give you an indication of we are increasing our adoption of cover crops compared to this number that was in the Leopold Center's survey, okay? So therefore, on a plot scale, large plot scale, we've been studying the phenomenon or the adaptive management practice of applying your nitrogen on a green surface. So a green application of nitrogen, injecting fall applied nitrogen into a living stand of cover crop. So we've been playing with that idea. We have 3 years of data, and basically the objective was simple. I wanted to see if the cover crops had the capacity to take up the full rate of nitrogen. Okay. Second, I wanted to see if that cover crop could interact with that nitrogen that was fall applied or interact with the physics of the soil matrix to reduce nitrate leaching. Okay. And then third, I wanted to see if there was a yield benefit or how does the impact of cover crops and fall applied nitrogen impact or influence the uptake of that nitrogen. So basically, we applied 180 pounds of anhydrous into a living stand of cover crops. Now I'm going to show you a series of pictures just to get an understanding of the logistics. So there was a good theory in mind, but you know, how does it really work out when you get to the field? I'm sure Lowell has a healthy respect for that thought. You can sit in the office, come up with something, but then to put it into the field, it's another thing. So this is in November 2012. We had a really good year. We also had a really good cover crop stand that year. Very wet and warm. Here's the injection of ammonia, anhydrous ammonia into the cover crop. And this is December, and the tillage radish is still living, okay? And it's still interacting with that nitrogen. Come March, you don't have as much surface cover. You only have the residue of the tillage radish, and this is what the cereal looked like on that same day, okay? On 2013, we got a late application of the cover crops, okay? That injection of anhydrous really did a lot of damage. In fact, I was fearful that we wouldn't get the cover crops to bounce back and recover, okay? Then we began to take pictures March, okay, starting to come back. You can still see where the anhydrous was injected. And there's April. So the cover crops actually responded to some of that nitrogen applied. Definitely, we had a response from the cereal rye, anything that had cereal rye within the mix. Okay, so then the idea was to try to figure out what are the benefits of doing this. Are there any benefits? You know, what's the risk? So, first of all, we noted that the cover crops had the capacity to absorb the full rate of N, or at least a high, very high percentage of that nitrogen that was applied. Over a 3-year period, we got an average of about 120 or so, 125, and about 130, 35 pounds per acre of nitrogen within the cover crop residue after we sampled. Okay, notice that you had a reduction over time, at least for the tillage radish, not necessarily for the cereal rye, and that came because the growing seasons each year were shorter due to the colder winters. So each year got colder. Here's the impact of those treatments, the cover crop treatments, on the distribution of nitrate within the soil. So we sampled down to about 80 centimeters, which is equivalent to about 2.5 feet. Okay, and you can see here when you don't have the cover crop present this is a 3-year average. You don't have the cover crop present, you do have more leaching occurring compared to if you fall apply into tillage radish, the radish, or into the cereal rye. So we could say that the cover crops have the potential to impact the distribution of nitrate after fall applying into them. Okay? The next benefit was kind of neat. We went back and mined the data, and we took soil temperature as we took the soil samples. And we found 2 dates over the last 3 years where there was a delta or a change in soil temperature by at least 10 degrees. And we picked those 2 dates. It was about 41 days. So this 0 day, this is the day of termination of the cereal rye. Okay? This day 42 is 42 days after the termination of that cereal rye. So this is about 3 weeks before planting in a normal year. And what we found was that, first of all, the sheer difference in concentration, and this is in the top 20 centimeters, so the top 8 or so inches of soil. This is what your new seedlings, as far as corn or soybean, would be interacting with. Okay? There's a significant difference between cover crop plots, okay, where you have the cereal rye, the mixture of cereal rye radish and then radish alone. And then when you look at the change in total inorganic N, both ammonium and nitrate, there's a huge difference in the amount of change. So if we were to take the slope of those lines, we could then do a small prediction and come up with a linear model that could give us the idea of the change in inorganic nitrogen when we get the most heat in the soil, when it's going from the early spring to late spring and the soil to begin to warm up. There's some biological interactions that's going on here that we have not measured yet, but we know that definitely there's an impact of cover crops. Another benefit, a potential benefit that we saw was the increase in nutrient uptake when you fall apply into living stand of cover crops or have cover crops present when you fall apply the nitrogen. This is taken at V6, and what you have in parentheses is just a percentage of the total uptake of those treatments. And this, we actually had different rates, and we just started this in 2014. And what you could see at each rate, despite rate, when you fall applied into the tillage radish, you had a higher percentage of the total uptake occurring at V6 compared to cereal rye and the control. Okay? The next benefit was actually higher yields. And it took me a little bit. I was kind of shy. I didn't want to show this because I had to prove it out. I had to proof it out. And what we saw was that we had different rates, okay, 80, 130, 180 pounds per acre, okay? And what you see here is the control, and you kind of see the curve. But then when you apply that nitrogen at the same rate into a living stand of cover crops, you got a yield response at each rate, which was pretty significant. Now, I don't know if we're going to see that next year, but it was pretty significant this year. So there was a significant difference despite rate. Anywhere that there was cover crops present, you had higher yields. Okay? When we did the economics, just a basic risk-reward economics here, and you consider the reduction in nitrogen, not only can you pay for your cover crops, but there was per acre profit upwards to $30 when you take some combinations here. Now, will that happen every year? Probably not, but we did see a response in this year. And so that leads me to our work, tile drainage field study, where we're in Lexington, Illinois, okay, high organic matter soils again, okay, and basically we wanted to further examine the ability of cover crops to stabilize fall nitrogen and compare that to spring-dominated systems, where you apply that nitrogen in the spring with or without cover crops. And so at the end of this, the idea is to not only know the impact of cover crops and the impact of nitrogen timing on corn yield, but to get some type of economics going where we can understand the risk and reward of integrating cover crops within nitrogen management systems of Central Illinois and the greater Midwest. So it was very nice to walk into a situation where the farmer was conservation minded. 9 years thus far of no-till before corn, and then, no-till before soybeans and strip-till before corn. And we kind of had a debate of whether we would continue to strip-till or not. And I said, why not? You're strip-tilling your anhydrous in, let's strip-till right into the cover crops. And so that's what we did this year. So actually, not only were we just injecting the cover crops in, but we're actually strip-tilling. And he wanted that strip-till, we know, because it creates that mound and you get good warm-up in the spring. So I sided with the farmer and we continue to strip-till, okay? His current method of applying nitrogen is about 60% in the fall with anhydrous and 40% in the spring with UAN. We're going to be close to that. And so we took this year, similar to Lowe and Mark David, we took this year as a year to set up, get some baseline monitoring done, okay? And we did so. Each one of these fields, so within the blue, represents one plot. There are 5 plots, there are 5 treatments, and they're randomly replicated 3 times. Each field is about 6.2 acres, which is about 72 rows. So it's a nice field scale study where farmers can actually relate to what we're doing here. So this is just a picture of the 3 laterals. Each lateral is 45 feet apart. They join about 15 feet from the monitoring station, and then that water converges into the monitoring station, and then that's where we take our water samples. So here's the idea of the setup. We have an alleyway. We can come in. Here's the control structure, similar to the Urbana study and the Douglas County study. And we have a precision box, and we have our sampler. We're also being solar powered, marine battery there, and communication systems. So it's a pretty neat system. When we do get flow, my graduate students get text, and then when the bottles are getting close to its capacity, my graduate students get text again. They go out and they collect the water samples, we bring them in, and we analyze them in-house. So we have 5 total treatments that we're replicating 3 times. We have a zero control, and some people don't like that concept, but I really wanted to see what the soil was releasing to the tiles without any nitrogen applied, because I really think that we are underestimating what soil is giving us for free by itself, okay, with good management. Okay, then we have spring-dominated systems where we have 20% of the nitrogen applied. This farmer loves to apply DAP, okay, so about 20% of that nitrogen in that DAP constitutes 20% of the total, and then 80% applied side dress with UAN, okay, and we do that with or without cover crops. Then we come back, we've already applied our fall nitrogen. We did that on December 4th, and then this system is fall dominated, where you have 75% in the fall and 25 with side dress in the spring, with or without cover crops. So we want to get an idea of the impact of the cover crops and impact of timing of that nitrogen application. And again, that nitrogen in the fall is strip-tilled into a mixture of cereal rye and radish. The total weight is about 200 pounds. So we got to monitor from about June to late October. We just took things out of the field because everything is frozen over. And so here, let's start here with the table, okay? And you can see here the precipitation, and then you can see the flow rated concentration of nitrate, and you can see where, when you look at the figure, you started off, you had a flush, we expected that, and then it kind of leveled off, and significant reductions compared to the first concentration due to uptake and good uptake and good yields from that field, okay? And then after harvest, you see, because there's no canopy, and no uptake occurring, you had another flush of nitrates coming through the system. So the system works, we're able to measure things. On average, we monitor about almost 12 inches of rainfall. Based on our load calculations, we were seeing 10 to 29 pounds of nitrate N loss per acre in this field. There are some variability of flow across the field, in every field there is, And so that's why we have to use the flow-weighted concentrations. When you think about the agronomics of things, we had a yield of about 225 on average across the field, so a pretty good yield there. We also measured uptake at V6, almost 30 pounds there, and then uptake at V12, we were considering that part of the total uptake, 117 pounds, and the grain took away 112. We applied the cover crops with a Hagie high clearance, okay? We converted that sprayer and applied the cover crops. We got a pretty good stand, okay? We were able to do that September 12th. Here's a picture showing the stand on November 8th. We did a fall sampling of the cover crops and determined that there was about 23 pounds of nitrogen in that cover crop from this stand with a biomass of 598 pounds per acre. And this is what it looks like after 1 week of growth. So we got in right before rain, and you have to do that when you consider using cover crops. So even though there's not a lot of residual nitrogen in the soil due to uptake from the bumper crop year, we can see when you look at the inorganic nitrogen concentration with depth, we can see already that stand of cover crops after 50 days of growth is having an impact on the distribution of nitrogen. And so we're going to go back and take another sample in the spring, about 3 weeks before planting, right before we terminate the cereal ride, and we're going to re-examine to see if this impact is still existing and if there's more nitrogen being taken up by the cereal ride that continues to grow in the spring. And the reason why we use the tillage radish cereal ride mix is because we need the tillage radish to get scavenges very early if you can get it very vigorously, if you can get it established in the fall. And then it winter kills, and the idea is that some mineralization may be taking place, and the cereal ride can either take that nitrogen up in the fall or spring as it continues to grow. And also you get that ground cover. So basically, to summarize, we got good baseline data. We were able to apply our fall nitrogen by strip tilling anhydrous into a cover crop mix. Our tile system is functioning properly. There's some tweaks that we're going to make to be more accurate. Okay, so I think that we're prepared to evaluate any differences that may occur due to treatments, and look forward to coming back next year to have a year's worth of data to compare with the experiment that's going on in Douglas County. So thank you for your time.